Welcome everybody, and thank you for coming to another lecture of the Saadeh Institute. One more in our series about from part of our research and policy forum on climate change and environment in the Arab world. Today's lecturer is Dr. Saadeh, who's an instructor in Oceanography at the AUB Geology Department. The title of his lecture is Seawater Intrusion in Greater Beirut, the Current Situation and Early Signs of Climate Change. And this is another in our lectures where we look at scientific research done by AUB professors as well as other scholars in the region, trying to see if we can spot any early signs of climate change taking place and what is the actual impact and what could be the most appropriate policy responses in the final analysis. And this is something that will come out of our forum on climate change and environment, where we bring together researchers and policymakers from throughout the region to discuss these issues. Dr. Saadeh, in his doctoral thesis, focused on seawater intrusion in the Greater Beirut area and its impact on water quality. He's a consultant now to the Litani River Authority, and before joining AUB, he was project manager of the Litani Water Quality Management Project. His interests are in hydrogeology, seawater intrusion, and its implications on groundwater quality. So thank you all for coming, and Dr. Saadeh, thank you for doing this, and the floor is yours.
Thank you for having me. I'd like to kick off this presentation by thanking AUB, specifically the Assam Affairs Institute, for allowing me this opportunity to present the results of almost a 4-year dissertation program that was undertaken by myself and a co-advisor from the university, this university actually, Professor Hamid Assaf from the Department of Engineering, who is with us today. Again, my thanks to him. I don't think this would have been possible without everyone's help. This research began in 2004, and it was done under the direction of the Department of Hydrogeology in the University of Aachen, RWTH Aachen. It began in 2004, as I just said, and with great difficulty at that time. Great difficulty because simply for the fact that there was no information, there was no database, there was no monitoring system. It was very difficult to get this project underway in the very beginning, but once it gained momentum, it became more of a scientific exercise to gather data, to analyze samples over the years, and then it was from there just a matter of time before we reached conclusion by simple analyses and using the latest computer softwares. I'd like to start the presentation with a slide of a quotation from a reference that I have on the Mediterranean and its hydrogeological problems that it is currently facing, by a professor that I met in Italy just a few years ago. He's an Egyptian by the name of Hamdi, Dr. Hamdi. And in that book it is quoted that many of the coastal areas in the Mediterranean will be subjected to some damage. A climate change, including the combined effects of more frequent and more intense rainfall and the rise in sea level, will mean greater flooding, erosion, as well as the intrusion of salt water into fresh water sources. So that is by no means anymore a secret. We all are facing this problem. All countries, all 18 or so Mediterranean countries, they are facing this problem. The only thing about it is that everyone has been monitoring it for years now, and they have come up with mitigation measures and what have you, except in our country here. Let me start by first discussing the phenomena of salt water, or some refer to as seawater intrusion, in this illustration here, which I've downloaded from a USGS journal, the United States Geological Survey. It's entitled Saltwater Interface in an Unconfined Coastal Aquifer, according to the Geiben-Herzberg relation. Now, this is a fancy way of saying that, and it's not entirely applicable. The Guyben-Hasbach relation says that whenever we have a drop of 1 meter in the water table, the interface, the saltwater freshwater interface just below it will rise by at least 40 times. Now this is empirical. Since that time it has been shown that this is not necessarily the case when it comes to actual field and geological conditions, but it gives you a very good idea of how serious it is when we over abstract or over pump fresh groundwater, as is the case here. This is a typical scenario where we have already advanced seawater intrusion. The interface is marked very sharply here. This is not the case in reality. In reality, the interface between fresh water and salt water can sometimes be hundreds of meters, even kilometers thick. So that would be actually the interface. This gives us a very quick idea of what saltwater or seawater intrusion is. Why is it such a problem, especially for coastal countries such as Lebanon? It all falls back to the issue of salinity. And salinity actually affects 3 different sectors. It is the industrial sector, the agricultural sector, and of course it affects the social constitution of any culture. Starting with drinking water standards, as we all know that there is a limit for it, guidelines, worldwide guidelines set the chloride content usually for drinking water at around 250 milligrams per liter. The same can be said for irrigation water, which is usually also set around that limit, 250 milligrams per liter. And even in industrial applications for mixing concrete, the ASTM C94 guideline places very hard restrictions on chloride for concrete mixed water. Usually should be less than 500 milligrams per liter. Now, for those of you who are a little confused between salinity and chloride, actually there are different manifestations of the same phenomenon, except that when we say salinity, usually the rule of thumb is that salinity approximately is twice the chloride content. This is a rough estimate of how to deduce one from the other. But basically when you have a rise in salinity, it means you have a rise in the dominant ionic species of those salts, and they are mainly NaCl, simple table salt. Seawater contains about 21,000 milligrams of chloride. Now, it is said that a mixing of only 1% could triple groundwater salinity, and a 5% mixing would increase salinity to over 1,000 milligrams per liter in chloride. Bayer, 1999. I'm always going to come back to this slide, so it would be very advisable if you would keep this well in mind, because all results are going to be compared to these values that we have here, to these mixing values. Another Barlow in 2003, prominent scientist, said that a contribution of 2% by seawater mixed with fresh groundwater would render the water unsuitable for public supply according to US EPA guidelines. So 2% is very critical. The 2% mixing is extremely critical because that would render groundwater unsuitable. 5% would raise it to over 1,000 milligrams per liter. Now, always keep that in mind. Let's talk about the area that's covered in this research that took almost 4 years of my life. It is Greater Beirut. It is actually delineated by 3 different municipalities: the Beirut municipality, the Baabda municipality, and the Alay municipality. It is very important to note that Beirut's population of 1.4 approximately is roughly almost a third of Lebanon's total population. spread over an area of 135 square kilometers. That gives us a very high density population in Greater Beirut, and most of that density population is actually concentrated in the southern suburbs of Beirut. Main causes of groundwater overexploitation in Beirut today could be attributed primarily to anthropogenic reasons, and secondly to climatological. The first one, the anthropogenic, I would attribute it mainly to network losses at over 50%. And this has been verified by contractors who have carried out that work in the past few years. I've been informed by those contractors that in some places in Beirut we have network losses in the domestic supply of water in excess of 50, sometimes even 60%. And in my humble opinion, I think this is really the crux of the problem here in itself. The second reason for these anthropogenic overexploitations are lack of a national water metering sort of system conducive of tampering. It is ironic in the fact that we today pay for our electricity as we go along, meaning that as much as we consume, we pay. So there's a meter for electricity. But we are among the very, very few countries in the world that doesn't have the same metering, but this time for water. And this lack of a national water metering, if you want, program, first of all, is conducive of tampering by individuals, and secondly, it instills a sense of not, shall I say, respecting the nature and the importance of water in our country. Meaning, I will give a very simple example. If someone were to travel and go abroad for a year and he would return, he would pay exactly the same amount of money to the Beirut Water Authority as another person who was during that period all the time in Beirut. So it is this sort of attitude that instills a sense of disrespect, if we should say, for the importance of water in the Middle East and specifically in our country. This is not the case anymore in Arab countries. The other reasons as well for overexploitation in Beirut is also, we have to attribute it to climatological factors. As we all probably know and heard the expression of global warming, global climate change, which basically boils down to two principles, and that is the increased annual temperature and a decrease in annual precipitation. And we are really experiencing both of these phenomena on a yearly basis in Lebanon and the Middle East. Let's start off first with the anthropogenic causes. These are some numbers that I've obtained from the Ministry actually of Energy and Power, Beirut's water budget for 2005 during the winter and the summer. I'm going to skip all of these numbers. They're self-explanatory. Delivered demand deficit percentage, we have a deficit of 35% during the winter and over 50% during the summer. Now this is a huge amount for the capital of Beirut. Meteorological data, on the other hand, which is part of the climatological reasons for overexploitation, is self-explanatory in this illustration here. I've tried to track the annual temperatures and precipitation average from 2002 until 2006, and I've obtained these from the Statistical Bureau at the airport, Beirut International Airport. If you notice, even in 2003, for some reason the data is absent, or half absent, shall I say. Anyways, I tried as best as I could to shall I say, track the data, and this is basically the trend we have in the last 5 to 6 years. As you can notice, temperatures have been on the rise since 2000, a gradual rise, and suddenly in 2006 we had a huge jump from about the average annual, from about, I would say, 22 to 24. But definitely the trend is an overall average annual rise in temperature over the past 6 to 7 years. Precipitation, on the other hand, has been more or less meandering, but from 2001 it has been dropping off. 2002, 2004, 2005 has been slowly diving, decreasing, until suddenly 2006. Now, this is very perplexing here, the data. But in a way, it is self-explanatory as well if you entertain the idea that global warming simply means a decrease in precipitation. That's right. But it also means that sometimes, in some years, you have a horrendous downfall in precipitation all at once, all of a sudden. And that is conducive of erosion and extremely high surface runoff. In other words, water loss. So when we had a dramatic rise in temperature in 2006, we had a lot of evaporation, a lot of moisture was sucked out from the earth and even probably from the sea, and it downpoured all of a sudden over Greater Beirut. Now, this in itself is not a very good sign. It doesn't necessarily mean that we've had more rain, that this is a prosperous event. Actually, what we need in terms of precipitation is snowfall rather than rain, which in our country is not even harvested. Now, going down and getting down to the actual raw data of the salinity values that we have presented in front of us. These values were taken over 2 years, between 2004 and 2005. 20 to 30 wells were selected, having a good geological coverage of the area, sufficient depth, that the wells were in sufficient working order, and so in total they had to be screened in order to be selected for monthly sampling. And these wells, most of them actually were private wells. I started out this presentation with the fact that we don't have a national monitoring program per se. So this is why in the beginning I had this great difficulty in selecting these wells. Most of them presented here are private wells. Few of them were public wells, and they were sampled on a monthly basis for about 10 to 15 different parameters. Here, specifically for this presentation, I have only presented salinity, in other words chloride, but they were also sampled for other parameters, chemical parameters as well. Each one of these lines is a different well. Some wells throughout 2004, 2005 had ranges of salinity in the 1000 range, some of them in the 2000. And as we're increasing, you notice that some wells were consistently over 3, 4, and even in this one, this specific one, which is actually a public well and not a private one, was more or less usually over 4,000 ppm, or in other words milligrams per liter in salinity. If we convert this value of, let's say, 4,000 to 5,000 milligrams salinity, that would be about half in chloride. So we would have about 2,500 to 3,000 milligrams per liter in chloride. Now remembering, if we go back to the initial slide, that a 5% mixing would raise the salinity of water to over 1,000 milligrams per liter. So imagine how much mixing we have in these cases here. A 5% mixing would raise it over 1,000. And most of these wells that I've sampled are well over the 1,000 ppm range. And that would be the 5% mixing. The 2% mixing renders it unsuitable for domestic use. So by deduction, I estimated that we had a mixing between freshwater and saltwater of no less than 10 to 15% in some cases, in some wells in Greater Beirut. And this is really nothing short of an environmental, I would call it, catastrophe.
So, which way is the time trend going?
October, November, December 2004.
Okay.
January, February until August, that would be 2005. So from left-hand side to right-hand side.
And is the trend at all scientifically indicative? It seems like it's erratic. But
It is.
It hasn't changed too much over time.
It is. This one changes a lot because it is a public well. And public wells are sometimes turned off, switched on and off. So that would actually depend, it would actually reflect pumping rates, distribution to different localities. The others, which are more or less linear, they actually reflect private wells where you don't have sudden over exploitation. But ironically, the wells with the highest salinities were actually the wells that belonged to the government, belonged specifically to the ministry or Beirut's water authority. Yes?
I just have a couple of questions here. Can you draw a threshold for the maximum chloride level? Like,
Yes, I could.
In this case, 550, right?
For drinking water, the threshold, if we convert salinity to chloride, the threshold would be down here.
Should be at 500 level.
It should be at actually for drinking 250.
250 for chloride, but
Yeah.
multiplied by 2 for salinity.
For salinity, it would be 500. Yeah, that's right. So the threshold would be right here in the middle.
Wow.
Imagine how far way beyond the guidelines we are for drinking water, way beyond the guidelines for concrete mixing, and way beyond the guidelines for irrigation. So this in toto is rendering the groundwater practically useless for any purpose whatsoever, industrial, consumption, or even agriculture. And this is way beyond the 2% mark. The 2%, this is the 5% mark here, the threshold. 5% mixing between seawater and fresh water. And we should never overtake it by half that, around 2% here. So this is actually indicative that the problem of seawater in Beirut is at a very advanced stage, and it is, like I said, it is nothing short of a catastrophe.
Just,
I'm sorry. Yes.
Sorry for interrupting you, but there's another issue about the location of these wells. I mean,
Yeah.
Can you please elaborate on this? Because the one, maybe it's not just that some of them are actually belong to the public or the government, but some are located in highly populated areas.
Exactly.
Maybe they relate to.
It's in the, not the next slide. It's in the one following that.
Which one is actually the one? Can you
This one.
highlight ones which you
Let's keep this one in mind here. This is the highest one that I had. The highest salinities recorded of all the wells. And this one is right here.
Wow.
This is right here. As you can see from this aerial or satellite image, this is the Beirut International Airport. This is August 2004, exactly 1 year later. These are chloride values this time, not salinity, but chloride. And as you notice, the problem of seawater intrusion or the problem of groundwater salinity is increasing dramatically from year to year, in just 1 year. And that well is actually this one here. The problem is starting out in the southern suburbs of Beirut, around the airport. It is less pronounced in Beirut proper, and it is barely present, barely noticeable in the northern suburbs of Beirut, Jdeidi, Jalidi. But primarily it has hit the hardest in the southern suburbs, less so in Beirut, and less in the least in the north. This comes as no surprise. We have the highest population density in these areas here. Everyone in this hall knows that. And this actually works in tandem with the problem of saltwater intrusion.
And you're talking about 2,000 milligrams roughly per liter? Around 2,000?
This one,
In the airport area?
in the airport, this one was 2,750 in August, milligrams per liter of fluoride.
Oh.
It jumped to 5,000 1 year later. We have another one which is very high here, 2,200.
Oh.
And these two were actually, these two with the highest values here, these were public wells, ironically, and not private wells. And these are the wells that show the highest chloride concentrations. Now, there are a lot of factors that play a critical role in the way the salt water is intruding into Beirut. These factors don't only include surficial, but they also include geological parameters. But let me go back one slide, if it's okay, if you don't have questions. Hydrogeologists use this trilinear diagram. It's known as a trilinear diagram or a Piper diagram as well. And it was sampled for August 2005. What I do with this software is that I take all of my wells that I sampled. Each one of these figures is a well. And I take all of the parameters that I sampled for these wells, which include calcium, sodium, potassium, magnesium, the cations here, and the carbonates, bicarbonates, chloride, and sulfate here, the anions here. And what this software does is that it superimposes them on the top diamond figure here. And this is a very handy tool for hydrogeologists because it tells us a lot about the mixing. And in this case, when I input all the data, all the raw data that I have into this Piper diagram for August 2005, which corresponds to what is happening here, this tells me that the interface, the saltwater freshwater interface, is actually still moving. Because if all of these figures were cluttered here in the left-hand corner of the diagram, that would mean that they are purely freshwater samples. If they were all cluttered in the extreme right-hand corner of this diamond, this would indicate that they are purely tapping seawater. That would be actually seawater here. But the fact that these wells fall more or less between the two indicates that it is a dynamic interface. The fresh saltwater interface is still dynamic, and it's still going on as we speak, and it's more or less halfway between these two extremes. This is a very extremely useful tool, and it gave us a lot of insight into this problem. And this is what we have today. More or less, I would hate to think where we are in 2008. There's a nice, I'd like to take a moment's pause here. There's a nice saying by Sir Winston Churchill back in the 30s, and he said, "The era of procrastination, of half measures, of soothing and baffling expedients, of delays is coming to its close. In its place, we are entering a period of consequences." And this was said back in 1936. In our case today in Lebanon, it is not a question anymore of climate change and the impact of that, and is it really that bad, and saltwater intrusion. I think we have a clear picture now from this presentation where we stand. It is no longer a question of are we entering a period of consequences. It is now a question of what do we do now that we have actually entered this period of consequences. Now, there are many conventional recommendations in combating or battling the phenomena of seawater intrusion. Some of them fall under the legislative approaches, the management approaches, the engineering techniques even, and the last one includes actually a national groundwater monitoring program. These are recommendations. I could spend hours and hours discussing each one of them and how the pros and cons and how they would be effective. But actually, these are conventional recommendations in the sense that most countries would actually dwell on these recommendations when they are still at the 2% critical mixing threshold, not when they have surpassed that, as is in our case today in Beirut, and we've reached probably 10 to 15%. For that, we need something different. We need immediate countermeasures. We require surgery. In my humble opinion, these immediate countermeasures that should be implemented with no question right now would be primarily to address the network losses, which we discussed. In some places they exceeded 50 to 60%. I think the problem inherently lies in that fact that this network is decrepit, it is archaic, it needs to be addressed. Once we can minimize those losses, it can never be cancelled out. There are always losses in networks, even in developed countries. But once we minimize that, then we can accurately address the issue of, okay, budget versus consumption. Another immediate countermeasure would be to suspend immediately the issuing of well permits. No more wells to be drilled, private wells to be drilled in Beirut, at least the coastal zone, and this would mean creating sort of a buffer zone, if you would like to refer to it as that, along the coast of Beirut. A buffer zone delineated by the Ministry, for instance, of Energy and Power, and in this buffer zone, no more private wells are to be drilled. Then, and only then, can we proceed with the conventional recommendations which can be implemented over several years and they are more relaxed. But right now, today, here, we need to do these two things. And with that, I conclude my presentation. Thank you for your attention.
Thank you. Can I ask Mark, the 1%, 2%, I should have interrupted you back then. You're talking 1%, 2% of what, the volume of water? Or?
Okay, that's a good question. I'll clear that out. Here it is. Clear that out, meaning 1%, if you have just one in 100 is salt water and the 99% is fresh water. So that's how critical it is. You're just barely adding a teaspoon of salt. And when you reach the 2% threshold here, that's critical. That's really critical. This is what the United States and a lot of European countries want to avoid. They address the problem way before it has reached the 2% threshold. The 5% would throw your freshwater salinity over 1,000. And as we saw in some of those wells, we have thousands of milligrams per liter in chloride content. So the problem has, in my opinion, surpassed the 2% critical threshold, even surpassed the 5%. We're now probably in the 10 to 15% range. And I dare to say that this is probably a point of no return anymore.
Well, that was my other question. Is this reversible?
this is, in my opinion, open to extended, shall we say, controversy, and we can spend days and months addressing this problem, but in the end it boils down to geopolitics, if I may say that. Currently today in Lebanon, with our limited means, it would be extremely difficult, almost impossible, to reverse this process.
Technically or politically?
Technically, in the first place; politically, in the second. This would usually, if we go to the conventional recommendations, the engineering techniques. What they do is, sometimes in countries, to push back the salt water, they inject back into the aquifers fresh water. Huge amounts of fresh water to push back that interface. The problem here is the government has tinkered with that. The ministry has tinkered with that, pilot projects, re-injecting fresh water, and they've gotten good success. But what they don't realize is that the problem of this intrusion is really the scale of it. These pilot projects are very misleading. The results are not indicative of the success that they think they have achieved. And I will explain that from a chemical point of view in just a few seconds. In our situation, they don't realize that it is so advanced that you need huge amounts of fresh water to re-inject back into the aquifer, push it out again. The question here is, where do we get that huge amount of fresh water? And if we do have that, do we want to inject it back into the ground just to push out the interface, or do we rather use them for a capital that is starving, that requires that fresh water in the first place? So you actually need a surplus that you can inject back into the ground. We don't even have that surplus. The very limited supply, freshwater supply that we have already is being lost. From a hydrogeological point of view, when we re-inject fresh water back into the ground and we take measurements, immediate measurements in chemistry would indicate that yes, we are getting fresh water back. There is this flushing process. But what they don't realize is that as soon as you stop injecting that fresh water and you take measurements again, suddenly all that fresh water is gone and we have salinity in our water again. Because even though you flush out the water that's in the matrix between the grains, you're not flushing out the salt that is adhering to the grains, to the matrix itself, to the aquifer grains, if you want. You're not flushing that out. So what they do is, usually here locally, they pump fresh water into the ground, they take immediate readings and go like, we've got fresh water in the ground, fantastic, it's a success story. Actually, I would advise them to inject that fresh water, and after a while take readings from the ground, from the aquifer, and then they would see a totally different story. That actually it's not anymore fresh water and it is actually salty water. The salt is still there. They have just flushed out the water between the grains and not the ones adhering to the grains itself. So to sum it up, the reverse process is extremely tedious. It takes a lot of time as opposed to the initial advance of seawater. Once that has happened, it is extremely difficult, and it's a very long process to push it out again, on condition you have an abundance of fresh water that you just love to re-inject back into the ground and flush that salt out.
and that spike rainfall year in 2006, all that water just ran off?
All that water that downpoured very torrentially, shall I say, in Beirut, what is happening to it is that it is not being harvested, and by that it is just running off, and they call it surface runoff, and it's ending up in the sea, probably in the same day. It is a very obvious manifestation. We see all our drainage network, flooding, producing those beautiful fountains. We cannot cross Abdulaziz anymore. We have to use the tunnel sometimes when it's really a very large downpour. And we have no measures whatsoever to harvest that rainfall. So what is happening today in Beirut, that Beirut is an island. And
just one thing actually. Isn't this problem really a product of the, let's say, the overpumping of the aquifer?
Primarily.
Which is mostly done illegal.
Primarily, of course.
And since really the problem is actually more or less is a water demand, water supply problem. I mean, there's a shortage of water in Beirut. And, some of the population actually compensate for this through pumping through, whether it is actually legal or illegal wells.
Exactly.
Beyond what is being licensed.
Exactly.
Can you elaborate on this, please?
Initially, that's why I would say initially it's a problem of exploitation, pumping. There should be, this water extraction should be regulated. And in Beirut, in Lebanon actually, it's not. So we have over abstraction, over pumping, over exploitation by illegal wells, even sometimes by legal ones. And this problem is even worsened by the fact that today Lebanon is undergoing a climate change. It is going to get hotter, and by that we're going to need more water, more fresh water. The government is not, at least in the near future, doesn't look like they are capable of supplying Beirut with more fresh water sources. So that's going to drive all of these factors together, is going to drive the people more and more to resorting to taking things and matters into their own hands, which means turning on that well for longer periods of times and abstracting fresh water from the ground, without any permit, without any consultation. This is, I hope I have answered the question that you have proposed. Yes, Serene.
Do you think that people can move, or is it a solution to move away from the coastlines upwards?
Moving, not the people, the wells. The wells have to be, the wells that are, shall we say, within this buffer zone have to be immediately, and these are the ones closest to the coast, they have to be shut down. These wells have to be shut, and this in itself is a tedious, this is a huge task. All of these wells here in this area, adjacent and parallel to the coast, have to be shut down. I would mainly focus on the ones here, start with these ones here, then move on to phase 2, which is Beirut. We don't have that problem here. So all of these wells in this buffer zone, for instance, I would shut them out, shut them down, make sure that they are inoperational anymore, and any wells, new well permits that are given should be outside, so they should be further away. But there is an inherent problem in that some scientists actually say that if we move these wells away from the coast, this is actually an invitation for the salt water to move further inland. So I do not necessarily subscribe to that, moving wells inland. I do subscribe to proposing a buffer zone here, no more welling here, ease off the aquifer, but not moving wells to this area here, but rather making sure that people in this region here primarily get their freshwater supply from sources, shall we say, outside of Beirut, which should be amply provided by the government through projects. So this is where the political issue and the unrest and everything comes into play. So it's a multifaceted problem here. It's not just a purely geological problem.
Politically, is it possible to know this?
I would think that there are projects in the pipe works of damming the Demur River, another one for damming the Zahrani. There are projects for damming the Ibrahim River to the north. A lot of projects. These would, on paper, be ample supply in fresh water for Beirut, were they conveyed to the population of Beirut. But as we speak right now, they are not in existence. They are just projects that have been undertaken, studies that have been undertaken. In the long term, these would be solutions. Yes, we need to find a new source of fresh water, the fresh water for Beirut, which we get mainly from Jeita, from the Jeita spring. By the time it gets through the network and reaches Beirut, it's already half gone. So if you want to give a blood transfusion to somebody, you've got to make sure first that his arteries are at least closed and stop the bleeding before you give him that transfusion. Once we stop the bleeding, the hemorrhaging, which is the loss in water here, and alleviate the pressure of the abundance of water that we have coming from Jeita, then we can see how much is the difference in demand and see how we can address that by these other projects which are still in the pipes.
Is this situation typical of much of the East Mediterranean? Can you compare with other areas, or is this a special problem in Beirut?
I cannot compare it to other areas on the eastern Mediterranean coastline, meaning Syria. It is. I have read a dissertation by a colleague of mine in Palestine. They have the same problem. The Palestinians have the same problem in Gaza, saltwater intrusion, even more pronounced. As for Lebanon, it would be a fair bet to assume that we have some intrusion, saltwater intrusion in the metropolitan cities like Tripoli, where you have a huge population. You may have rampant over-abstraction as well in there. So they are not very unlike Beirut. You would have certain stages of saltwater intrusion there. I wouldn't say that for the cities in the south. They vary in different stages of seawater intrusion, but I think Beirut would definitely be the most advanced when it comes to this phenomena, Heidi. But I wouldn't be surprised to find it in the other coastal cities of Lebanon.
Thank you very much.
Thank you.
Thank you, Salim, for setting it up.